My name is Phil Coelho. I'm Chairman and Chief Executive Officer of Thermogenesis Corp. I'm here today to talk about the AXP Auto Express platform. This is a new technology which is capable of harvesting up to 97% of the rare mononuclear cells from placental cord blood into a product that looks like this. The recovery of 97% is very important because these are the rare cells that are able to cure patients of leukemias, lymphomas, and more than 60 genetic diseases, all of which are lethal. This technology is able to accomplish this harvesting with closed, sterile, functionally closed, sterile bag sets. And this means it does not require clean rooms, and it can be manufactured at the rate of 6 units every 40 minutes. Let's take a look at how it works.
To expedite the process, make sure that fully charged AXP devices, processing sets, the docking station, computer, and centrifuge are readily accessible. The lab technician begins by removing the AXP processing set from its packaging and placing it on the bench. This will make it easier to perform necessary preparatory steps, such as labeling. There are 4 important steps to perform before labeling. First, clamp the DMSO line. Next, turn the valve 90 degrees. And fold the freezing bag to express air from it. Now, turn the valve to a 45-degree position so that no air will return to the freezing bag. The bag should have a concave appearance, indicating that all air has been successfully removed. You are now ready to begin labeling. Hang the cord blood collection bag. Scan the blood unit ID on the cord blood collection bag. The printer will automatically create barcode labels for all sampling segments and bags. This will ensure traceability through decades of storage. Before labeling the freezing bag, wipe the bag with 70% isopropyl alcohol. Label all blood bags and sampling segment pillows. Now, attach the AXP processing set to the collection bag. Open the fluid pathway. When all the core blood is transferred to the AXP processing bag, heat seal the tubing in 3 places and disconnect. Remove the collection bag. Properly dispose of clot filter and collection bag. Thoroughly mix the contents of the processing bag. Gently squeeze the sampling pillow of sampling segment 1 to fill it with blood. Heat seal tubing in 3 places and remove. This integrated sampling segment provides a blood sample that can be used for testing. The processing set is now ready to be placed in the AXP device. AXP devices should be kept in the docking station to maintain their battery charge. Verify that the battery LED on the selected device is green. This indicates the device is fully charged. Use Express Track to complete the daily functional check on all devices prior to use. Orient the processing set as shown to ensure ease of loading. Open the freezing bag carrier door. Fold the minor compartment of the freezing bag over the major compartment. and place it inside. Carefully position the tubing, ensuring that the port flanges are properly in place. Close the door. Upon closing the door, you should hear an audible click. Turn the device and open the large clear door. Place the processing bag into the cavity and the valve into the valve actuator cuff. Secure the F fitting. Close the clear door and turn the device so that the RBC bag cavity is facing you. Place the DMSO line into the RBC bag cavity, making sure the DMSO filter rests in the groove designed for it. Close the clamp on sampling segment 2 and place it in its specially designed recess. Position the tubing and place the Y fitting over the hook so that the pillow lies over the DMSO filter. Position the RBC bag over the cavity and insert the bag sampling port into the RBC notch. Finally, fold down the pigtail on the processing bag and press the bag onto the bag hanger. Check device closely to ensure that there are no kinks in the tubing and that all tubing is inserted securely into the tubing channels. Open a sample profile in AXPtrack by scanning the device ID, blood unit ID, centrifuge ID, and processing set lot number. Determine the weight of the device and balance it with another device using the weight compensation cap or use the specially designed counterweight. The cap can be used to house additional balancing weights. Place each device in a centrifuge bucket, making sure that the left and right edges of the RBC bag are tucked beneath the flanges of the RBC cavity. Orient the devices in the centrifuge so that the clear door and arrow on the bag hanger point toward the center of the centrifuge rotor. Manually move buckets to ensure they swing freely. Now you're ready to begin the centrifugation process. High-speed spin should be performed at 1400 RCF for 20 minutes. Low-speed spin is then carried out at a setting of 80 RCF for approximately 10 minutes. Consult your centrifuge operator manual for the proper RPM setting.
So now the blood has been transferred into the individual AutoExpress bag sets. Those have been loaded into the AutoExpress devices, which have then been transferred and inserted into the centrifuge cups so that up to 6 can be processed at one time, and centrifugation commences. During centrifugation, the red cells and the mononuclear cells separate themselves out for harvest. The valve is opened and the red cells begin transferring directly to the red cell bag, and the optical sensor tells us exactly when that part of the process should stop and initiates the transfer of a precise volume of the mononuclear cells to the freezing bag. When that has been accomplished, the operation is over, the centrifugation comes to a stop, and at the end of the run, the entire data set that describes this operation has been automatically recorded for later retrieval.
Remove the weight compensation cap from the device before taking the device from the centrifuge. A green cycle LED on the device will indicate that the run has been successfully completed. Remove the processing set from the device, starting with the RBC bag, sampling segment 2, and the DMSO line. Next, unhook the processing bag and release the F fitting from the groove. Open the freezing bag carrier door and remove the freezing bag. Place the processing set on the bench. Place the unloaded device into the docking station for transfer of all processing information. Downloading of the data will begin automatically. All information is clearly displayed. Processing reports can be printed and saved. Separate the RBC bag from the processing set by heat sealing in 3 places and attaching the bag. The RBC component may be used for sample testing. Open the clamp on the sampling line. Squeeze pillow to push the fluid into the freezing bag. Close the clamp. In preparation for post-processing sample removal, orient the bag so that the buffy coat is near the port. Mix the contents of the freezing bag thoroughly. Open clamp to release pressure on the sampling pillow. Fluid will now move into the pillow. Now, invert sampling pillow and squeeze it to express air back into the tubing and push excess fluid into the freezing bag. Close the clamp on the sampling line. Heat seal and remove sampling line. This blood can be used for testing. Pre-chill the freezing bag containing the buffy coat to 2 to 6 degrees Celsius. Aspirate an appropriate volume of DMSO solution into a syringe and prime the DMSO line. Position syringe in the syringe pump and start adding the DMSO per your validated process. Heat seal and remove DMSO line. Now place a hemostat on the tubing between the freezing bag and the F fitting. Remove this excess air by turning the valve and releasing the hemostat. Gently press and turn the freezing bag, allowing all the air to move into the processing bag. Once all the air has been expelled, gently express enough buffy coat to fill the tubing up to the F fitting. Close the hemostat and turn valve back 45 degrees. Place the freezing bag in the fill seal jig. Place one heat seal close to the freezing bag. Release the hemostat, remove the freezing bag, and make 3 heat seals, creating 3 sampling segments along the line. Heat seal and attach bag from the remaining processing set. Heat seal the top channel between the major and minor compartments of the freezing bag. Place the freezing bag in the fill seal jig. Heat seal the bottom channel between the major and minor compartments of the freezing bag. The freezing bag can now be inserted into an overwrap bag and placed in the stainless steel canister for controlled rate freezing and storage.
So here's the final product. The mononuclear cells are within the bag, the cryoprotectant has been added, the label has been applied, the bag has been inserted in the overwrap bag and placed inside the protective canister, where it's now ready to go to the bioarchive system, which will provide an automatic controlled rate freeze and then robotic insertion in liquid nitrogen, where these cells should remain viable for decades. I hope you will agree that the AXP Auto Express platform process was straightforward and intuitive, but if you have any questions at all, please refer to the operator's manual, and if any questions remain, contact us right away.